Today we are learning about similar polygons. So similar polygons relates to 6162 lesson on ratios and proportions. Similar polygons are where we have corresponding angles are congruent. It is the same type of shape, but our sides aren't congruent. Instead, the sides are proportional, like we were dealing with yesterday, right? Proportion. So if we had ABCD, similar to EFGH, we would use this little squiggly sign right there to show that it's similar, right? So you notate it, and just like congruent, order is important. A and E would be congruent angles. So would B and F, C and G, D and H. And again, sides, not the same, right, would be the first two letters are proportional, right? AB to EF would give us the same ratio as BC to FG, and so on. CD to GH, AD to EH. We would actually call this the scale factor of those two shapes, right? So, like if all these were 1 and these were double that, right, it would be a 1 to 2 scale factor. Right? So, given the similarity statement, ABC similar to XYZ, list a pair of congruent angles, right? Just from the statement, A and X are congruent, B and Y are congruent, and C and Z are congruent. Next, check that sides are proportional. So this means AB is similar to XY. Right? Plug it in. AB is 9, XY is 12. So that's 3 to 4 so far. And then we're going to check that the next letters, BC to YZ, are those the same exact ratio. BC is 15, YZ over here is 20. That's also 3 to 4. And for the last part, then AC and XV. We've got AC is 12 here, XV 16, which is also 3 to 4. So all of them are the same, right? And their statement of proportionality is all those pieces happen to equal 3 to 4, or 3/4. Given element O is similar to WXYZ, list the congruent angles and proportional sides. Right? So L, N, O, this is the quick way to do it. List all the angles of the first one, and then going down, WXYZ, congruent to W, congruent to X, congruent to Y, congruent to Z. So again, it's not based on how can I match up the shape. It is based on that original statement. Next, doing the same with letters, LM, MN, NO, LO, to WX, XY, YZ, and WZ for our proportional sides. Next, if two polygons are similar, the ratio of their corresponding sides is called scale factor. Right, I did talk about that in our first problem. The scale factor was 3 to 4. The numbers are listed in order of which one was listed first in the statement. Meaning, if we were comparing these two, it's the sides of LM to the sides of WX, right? So these were all 5, so these were 7, right? We would then say 5 to 7, given this statement. If they gave us the statement the other way, WXYZ similar to LMNO, then the numbers would flip, right? 7 to 5, right? So just a heads up, it is important in terms of order. What is the scale factor of ABCD to QRST? Right? So find AB and QR, compare them. Double check that those match with BC and RS, if we have those values, and then, right, or the ones we do have to verify. So AB is 12, QR is 6, 12 to 6 gives me 2 to 1. Right, double checking with my other ones. How about CD, which is 16, over ST, which is 8, also 2 to 1. So 2 to 1 is my scale factor. A lot of time I'll write SF is 2 to 1, or you can write it 2 to 1. Okay. What is X? X was BC there, so we do 2 to 1 equals BC, right? So again, where was X? BC. So BC compares to RS. Right? Now in this case, we know what RS is, but it's in the picture. RS is 4. So 2 to the 1 equals what number over 4? Cross multiply, we get 8 equals X. Determine whether the polygons are similar, and if they are, write a similarity statement, and find the scale factor. If they weren't, we'd be done. So again, double check your angles are equal, right? So I'm going to start with W. W is a right angle equal to angle J. Next, so these two congruent. Next, we'll go to the congruent mark 1. So Z and F are congruent. Y and G are congruent. And X and H are congruent. Now note, I was very careful to keep figure 1 and figure 2 in that order of my statement, so then when I make a similarity statement when I'm done, it's easy for me just to list out W, Z, Y, X. It's similar to the other shit, but we're not quite there yet, because this is only half the picture. My angles are similar, what about my sides? So it's going down the sides, 20 and 16, looks like 4/5 to me. Does that equal the next set? 25 to 20. And does that equal the next set? 30 to 24. And does that equal 15 to 12? Right, those all need to be equal, so divided by 4, I get 5 to 4. This one divided by 5, I get 5 to 4. And so far, they all do equal 5 to 4. So we are similar, right? This is a guess, right? We needed both sides proportional, angles congruent, and now I've got WZYX is congruent to, similar to, very different, JIGH. And that's how you can use your angles to help you out. Could you have a different way of doing that? Yes, we could have done, WXYZ is the same as JHGI. Yep, it's okay that way as well. Or JHGF. Sorry, my F was sloppy. Looks like an I there. Where's F in your diagram? Now it looks like an E. There it is. Okay. Moving on. Solve for X. So go ahead. Solve for X on that one. Now in this case, EF equals X. So EF to NP equals, and then do a different comparison, because notice we have all the other sides. So I can just do first two letters, ED to NM. And now when I fill it in, X to 20 equals 9 to 12. Cross multiply and divide. X is 9 times 20 divided by 12. 180 divided by 12 gives me 15. For that last statement, make two triangles, similar quadrilaterals, find their perimeters and compare. What do you find? You'll find that the next part is true. Our similarity statement, our scale factor, pardon me, is equal to the perimeter ratio. Okay. So far we have perimeter ratio equals scale factor. So does ratio of sides. We will add more equations to this throughout the year. We'll get into what about area? How does area compare? We'll also get to what about volume? Volume of three-dimensional units. How do those compare? So how would we prove this? This is very similar to the one we did yesterday where A1 equals KA2. The difference is they start us in this format. Right? Now, given ABCD similar to KLMN, we can make that statement by definition of similar figures, right? Right? So we're basically starting from this right side and trying to prove the left. So what you're going to do is we have all those, right? Those are a scale factor equals some number. Solve for each piece. AB equals X times KL. BC equals X times LN. Remember, basically multiply both sides by ln. Multiply both sides by kl. Same thing here. CD, multiply both sides by mn. And AD equals x times kn. Right? Now, you want to start with one piece and build the rest, right? How can we build the numerator, right? So first off, we got AB equals xkl, and this is important to know how to do it. This is in multiple lessons, so you need to know how to do it. And we are going to add the other three sides to both sides. So plus BC plus CD plus AB to both sides. Giving us AB plus BC plus CD plus AD equals xkl, and then the rest of the math. BC plus CD plus AD. Some people will want to add like the left side to one side of the equation and add the right side to the other. You can't do that. That is two steps in one. You were adding and substituting. Substituting is its own steps, so that's what we're going to do now. I'm going to substitute this for BC, and this for CD, and this for AD here, right? So now we're plugging in. The left side looks good, right? The left side looks like that numerator. The right side needs some fixing. We got xkl plus x, again, BC with lm, plus xmn, plus xkn. And now all these pieces have an extra x in them. We need to kind of greatest common factor the x out. So if we take the x out, we've got kl plus lm plus mn plus kn. And that looks an awful lot like the denominator, which is great. So now we have numerator on one side, something that looks like the denominator on the other. And so we're going to divide both sides by KL, LM plus MN plus KN to get our answer. So we get that at that point we're kind of done with the proof. Just got to clean it up. That x equals AB plus BC plus CD plus AD. Right? Perimeter of one quad over the perimeter of the next quad, which is equal to each scale factor, right? And so on, right? Those all equal the scale factor. Now, you technically wouldn't need all four of these to make the point, right? You just need one. So that wraps up this. Well, we got a couple more problems to go. Right. Find the scale factor of the left to the right one, solve for x. So in this case, AB is 10. That's the first two over here. FG, so 10 to 15 gives you 2 to 3. Next up, solve for x. So we've got 2 to 3 equals the side with x is AE over the side without x would be FK. Now we've got AE over FK. Finding the value, we get x over 18. In this case, we've got a little bit of a rule. 3 times 6 is 18, so it's 2 times 6. X is 12. That's 2 times 6. Solve for the perimeter of A, B, C, D, E. Right? So we have the scale factor. We're going to go 2/3 equal perimeter of the left shape over perimeter of the right shape. Okay. Now we have information for perimeter of the right. Perimeter of the right equals all those sides added up together. 15 plus 9 plus 12 plus 15 plus 18. Right, so we've got 30, another 30, 60. We got the right side perimeter 69. So we're going to plug that in where that goes. So 2 to 3 equals, we don't know, over 69. And the rule is times 23. So PL equals 46. Perimeter is units, so I'll write units in there. And that is how, without knowing all the sides, could we have found every single side using our scale factor? Sure. Would that take a long time? Yes. So this was a quicker way of doing it. Found one perimeter and had the scale factor to find the perimeter of the other. Next, if two polygons are similar, the ratio of two corresponding lengths in the polygon is equal to the scale factor. Some would say, isn't that what we've been talking about the whole time? But this is beyond that. They're talking about not just sides are similar, but so are heights, so are altitudes, so are angle bisectors, so are perpendicular bisectors, and so on. Right? Like everything we learned in chapter 5, those are all similar. So in this case, they're saying, this is the median. These are both 48. This also is the median. These are both 40. What is Km? Well, we can do, right, what's the scale factor? 48 to 40. That's going to give us the scale factor of 5 by 8. We got 6 to 5. Needs to also equal median on the left, which is Km, over median on the right, which is 35. I see a rule of times 7, so 6 times 7 gives us Km is 42. Right, so that's what they're talking about. Now we can even go beyond just sides. Next, do we have enough information to determine if the polygon is similar? Check it out. So we've got angle reflective, we've got parallel lines, and these are also parallel here. So these are right angle, this one's a right angle, right? So some quick math, these have to add to 180, and this right angle goes both ways, right? Because these had to add to 180. So far we've got 2 angles are good. 3 angles are good. Lastly, right, if we extend the lines, we'll see those are corresponding bottom left, or sorry, bottom right. And so all our angles are good. Next, check up your side, x to 2x for this side. And we also got x to 2x for the other side. So check again, y to 2y, and 2y to 4y. So those are all equal to 1/2. So yes, they are similar, and scale factor is 1/2. And similarity statement. On this one, you can just kind of go with the flow a little bit. ABGF is similar, right? Kind of the way we proved them, going that way. Going outside, ACDE. That wraps up this lesson. Always send an email if you got questions.
Hi.